Good day. You should have completed observations, copying out the different information. And one thing we're going to notice is that sugar solution did not conduct electricity, and so we want to talk about that. So sugar, the sugar we use, many different types of sugar, but we use sucrose, and that's the kind you buy at a store typically, and it's C12H22O11. Well, sugar, when you throw it in water, it dissolves, and so we go boom, we write the formula for sugar, and then we put S for solid. Then we said we've added water, and now we write aqueous. So it does dissolve, no problem. But when it dissolves, it does not dissociate. So we're not ending up with any ions because it is simply molecular. It's covalently bonded together. So what happens? Well, we get no ions to complete the circuit. So sugar is a poor electrolyte. It has nothing to go between the electrodes to allow the circuit to be complete and electricity to flow through the wires. So here is an attempt at a diagram, and I may have to zoom out a bit. And this is what you'll be copying. So from grade 9, you should know this is a schematic symbol for a cell. The long bar represents the positive electrode, short represents negative. We have an electrode here, an electrode here. In what you saw was going to be those filaments. The electrodes you used earlier in the lab would have been carbon rods. This electrode has a positive charge, it's hooked up to the positive terminal, and this one has a negative charge. So I've drawn the sugar molecules as sort of blobs. C12H22O11 is what it says in all of them, but you don't see any ions, don't see charges. And so they're largely unaffected by the charges we're trying to build up on the electrodes. It also reminds us that we threw this in water. Since we have no ions to complete the circuit, this does not conduct electricity. So this is why a sugar solution does not conduct electricity. It's because it's covalent or molecular. No ions, you don't have an electrolyte.